10.1, the three-dimensional coordinate system. What you should learn. Plot points on three-dimensional coordinate system. Find the distance between points in space and find the midpoints in space. And write equations of spheres in standard form and find traces surfaces in space. So we're going to talk all about the 3D coordinate system. And basically what it is you get a 2D coordinate system right here. Right here's my XY coordinate system. And you also have a Z value. So it's like the corner of a room, right? So here's the floor, here's a back wall, here's a side, right? The floor is an XY plane. The side wall here is a YZ plane, and we have an XZ plane. And this is, by the way, this is only the positive version. These actually extend out to the negative version as well. Like this is negative X goes over here, negative Z goes down, and then Y goes back. So there's actually a whole 3D spot you can do it in. And this is what it looks like in geometrically, right? 3 planes crossing each other. Okay, so let's figure out how to plot a point. So first we always start off with like our little base graph here. Then you make this one diagonal. The diagonal one, here's your X, here's your Y, here's your Z. And actually we're gonna plot more than this at one point. We'll plot a point that's like 3, 4, and 6. Well, then we'll plot 2, -3, and 3. Let's talk about how to plot these first. So here's my grid. We'll just do one on the positive to start off with. 1, 2, 3, 4, 5, 6. Okay, so we kind of want to go, this is X, Y, Z. So on the X, we're going to go, so this is kind of the idea. On your X, you're going to go 3 on your X. So 1, 2, 3, so right here. And then from this spot, you want to go 4 on your Y. So you want to go like this direction. So 1, 2, 3, 4. Notice how it doesn't line up perfectly because you're starting further back. So it's like 1, 2, 3, 4. And then from that spot, you're going to go up 6 to the Z because Z's up and down. So you can go like 1, 2, 3, then 1, 2, 3, 4 over here. And then you go up 6, 1, 2, 3, 4, 5, 6. Again, it should not line up perfectly because you're in a 3D space. And we're like starting further back. We're starting below the actual line. That's the way it kind of works. If you're having a hard time with that, what we do is this. Your X is going to be 3. So on the 3 of your X, we're going to draw a line parallel to the Y through that line of 3. Like that. And then our Y is 4. So on the 4 of your Y right there, we're going to draw a line that's parallel to the X. So try to make it parallel to the X. That'll be perfect. Mine is not perfect. I'm going to try to do a little better. It's like that. So this is where we're at when we're at 3, 4. So 3, 4 is just 3 on my X, 4 on my Y. So we're right there. Now we got to go up 6. You might go, how do I go up 6? Well, we're going to try to do the same concept. We're going to try to draw a line parallel to that point there that we have to the Z. So we're going to draw a line parallel to Z. Right, so straight up. And then I got to come across. How do we do that? Well, we're going to use this line here. It's this diagonal from there to there. And I want to draw a line parallel to that through 6. My Z is 6, right? So 1, 2, 3, 4, 5, 6. So we're going to try to like match this line up here. So like right there. That point right there is the point 3, 4, 6. Right, in 3D space. So again, a lot of times I like to think about this. I just go, okay, I'm starting at 0, 0. Then I'm going to go 3 on my X. Then from there, we're going to go, from that spot, we're going to go 4 on my Y. And then from that spot, we're going to go up 6 for my Z. So that's the way graphing works. So you could either go, okay, 3 in your X, then from that spot, go 4 over your Y, and then from that spot, go up 6. Or you could try to make lines are parallel. So go lines parallel to your X, to your Y, a line parallel through that point they match, through your Z, and then kind of connect it all. Okay, so how about the next one that has a negative value? So normally I'm doing the same grid, but that grid I kind of did all this stuff too. So I'm going to do a brand new grid. So negative values, you actually extend them. So that's like, this is Z. This will be negative Z down there. This is X. Negative X will go over here. And then this is Y, and negative Y will go over here. Like that. So we're going to try to, so the space, I'm going to try to go like the faster way. So we're going to go to my X, so right there. That's where I'm at currently, right? And then I got to go -3 on my Y. So Y usually goes this way. I have to go back 3 from here. So 1, 2, 3. Like, so we would like, if we did like this, we're going to do the same thing. So like 1, 2, 3. So from this spot, we want to go back 3. 1, 2, 3. It's like right there-ish. So I'm like 2 my X, 3 my Y. Then I got to go up 3 my Z. So 1, 2, 3. So right there. About. That's where that point is, right? So in this one we went 2 my x, and then we went back 3 of my y, then we went up 3 of my z. So you get a point about right there. So that's how you plot in 3D space. Distance to midpoint formulas. So they're actually very similar to the way they are in 2D space. Only difference is now for the distance formula, we add a third component, which is the z's. That's it. Exact same formula in 2D space, right? A squared plus square root of a squared plus b squared. In 3D space becomes square root of a squared plus b squared plus c squared, because of the third plot, the third dimension. So that's all it is. So if I was doing this problem here, I want to know the distance. x1, x2, y1, y2, z1, z2. The distance formula is just going to be square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. There's some type those all in. So I'm going to get negative 2 minus 3 squared plus 4 minus 1 squared plus 1 minus 0 squared. So we get, this is going to be negative 5 squared, which is 25, 3 squared, which is 9, and then 1 squared, which is 1. So I get 10 plus that, square root of 35. That's the distance between these 2 points, square root of 35. Right, so, kind of like that. Okay. Midpoint formula, the exact same concept. You're just adding a third component, which is the z coordinates, this point. So it's the exact same concept. This midpoint of 2 spots is this right here. Third spots, you just add a third component. Super easy. So I want the midpoint of this. You're basically taking the average of each one. So for my x, it's going to be 5 plus 0 divided by 2. For the y, it's going to be negative 2 plus 4 divided by 2. And for the z, it's going to be 3 plus 4 divided by 2. So we get 5 over 2, 2 over 2, and 7 over 2. Or a little bit reduce 5 over 2, 1, and 7 over 2. That's the midpoint of those 2 spots. So right, 3D space is super easy once you have the basic formulas. How about an equation with sphere? So remember, sphere is 3D. Well, it's pretty much the equation of a circle, just we add the third component. So it's h, k, and j now. Just like a circle, we just have that new component added. So let's do this. Find the standard equation of a sphere with the center of that and a radius side. Does this sphere intersect the xy plane? Right, so our formula is going to be x minus h squared plus y minus k squared plus z minus j squared equals r squared. Let's plug in our points, h, k, j. So I get x minus 2 squared plus y minus 4 squared plus z minus 3 squared equals 3 squared, which is 9. So that is our formula. Now, does it intersect the xy plane? Well, we could figure out logically, but we can also do this. If we kind of wanted to graph it just real quick, right, it would be at 2, 4, and 3. So 2 this way, and then 4 that way. 1, 2, 3, 4, and then 3 up. Right? Now our radius is not, r squared is 9, but radius is 3. So we're just going to go 3 down, 3 right, 3 up, 3 left. And kind of get a sphere. Now it is 3-dimensional. So it's going to look kind of like this. Right? 3-dimensional. But the key here is you went 3 up from the, this is the xy plane. XY right there. Should have done this, sorry. Right? That's XY plane. You went from the XY plane when we went 2 this way and 4 this way. We went 3 up. Our radius is only 3. So we're not going to, like, we'll touch it, but we're not going to intersect it. Like, it will touch the XY plane, but we're not going to go through it. So does the sphere intersect the XY plane? No. If the radius was 4, then yeah, we'll go right through that bad boy. But it's only 3, so we're just going to touch it. Example 5, find the center and radius of the sphere given by this. So we kind of, this is kind of conic section review. We're going to do the same thing we did with conic sections. We're going to rearrange all the x, the y's, the z's, and set it equal to some constant. And then 2, we're going to do complete the square. Okay, so let's do that. So rearrange it. X squared minus 2x. Give a little space, and then next we're going to do the y's. So y squared plus 4y. And then we'll do the z's. So give a little space, plus z squared minus 60. And then we want to move the 8 over. So we want the contents on the other side. So we have that. And now we just have to complete the square like 3 times. So this one, -2 divided by 2 squared equals -1 squared, which is 1. So +1 plus 1. Next one, 4 divided by 2 squared is 2 squared, which is 4. So +4 plus 4. And the last one here, -6 divided by 2 squared is -3 squared. So 9. So +9 plus 9. Right? And then we simplify the left-hand side. So this is going to be x minus 1 squared, right? So always the thing before you square it. Plus this side, y plus 2 squared. Plus this side, z minus 3 squared. And then we add up all these together. I get 10, 14 minus 8 is 6. So 6. So that is center in the, oh, I have to find the center and radius. So the center of our sphere is going to be 1, -2, 3, right? It's that opposite. And our radius is going to be the square root of that, square root of 6. So, well, just square root of 6. So that's our formula for our center, or for our sphere. That's our center, and that's our radius. And that's the lesson.